Welcome team, we're going to talk about binomial expansion of 1 plus x to the power of n, where n is not a positive integer. In the past, in Pure Maths 1, we looked at binomial expansion when we had something like, say, 1 plus x to the power of 2, or 3, or 4, 5, 6, 7, 8, and so on, and we learnt how to do that. When we're expanding 1 plus x to the power of n, this becomes n choose 0, and then we multiply it by 1 to the power of n, and x to the power of 0, which simplifies to just n choose 0. Then the next term would be n choose 1, and that would be multiplied by the 1 to the power of n minus 1, plus x to the power of 1. And you go on and you can see that this would be how the expansion plays out. Okay, that's what we did in Pure Maths 1. Another way of writing this is in this form here. Okay, that is the same thing. And we're going to use this form here to help us with binomial expansion where n is not a positive integer. Alright. The important differences that we need to be aware of when we are expanding a binomial where we've got a negative power or a number where n is less than 1 is that the series will be infinite, and so we're going to have to cut it short in some way, and we also know that the expansion is going to be only valid for the modulus of x is less than 1. Okay, so we'll have a look at this example here. We've got 1 plus x all to the power of negative 3, and so we're going to have 1 as our first term. Our next term will be the minus 3, which is that power, multiplied by x. The next term, we're going to have minus 3 times minus 4, so we drop down a power, and then multiply that by 2 factorial over x times x squared. The next term is going to be an x cubed term, see we're going up in powers of x, but it'll be minus 3 times minus 4 times minus 5, and that will be over 3 factorial. And then the next one, minus 3 times minus 4 times minus 5 times minus 6. We've added another one, minus 6, and then it'll be 4 factorial, and that will be the x to the 4 term. And then you can simplify that out and get this as your answer here. Okay, and in the case of a negative power, you can see that that sequence will go on as an infinite sequence. And we know that when x is less than 1, the binomial series converges and it has a sum to infinity. Just as when we looked at geometric sequences, series last year, we found that they could converge when r is less than 1 and where r is the common ratio. Now, if you're a little bit confused about that, that's okay. Let's just get into the exercise and try a few examples. So I've got 1 plus 3x all to the power of 5. So what I'm going to do here to expand it is I'm going to have my first term is going to be 1. My second term is going to be minus 5 times 3x. How many terms do I have to do for this? I think I have to go up to my x cubed term. My next term is going to be minus 5, and remember we go up a power, into minus 6, all over 2 factorial. See, this is what we're doing here. Okay, and then and that's going to be multiplying by 3x all squared. My final term which I need is an x cubed term, and that is going to be minus 5 times minus 6 times minus 7 all over this time 3 factorial, and that will be multiplied by the x term, 3x cubed. And then it would go on infinitely. So let's simplify this. 1 plus negative 15, so negative 15x. Now the next one, I've got minus 5 times minus 6, which is positive 30 divided by 2 factorial is 15. And then I'm going to have 15 times 9, having a mind block here, so 135, is that right? 135x squared Nice. Okay, the next one is going to be a negative number because we've got minus 5 times 6, minus 6 times minus 7. Now, 30, we're going to have, let's see what that is, minus 5 times 6 times 7, and we're going to divide that by 6, 3 factorial is 6. Then we're going to multiply it by 27 because 3x cubed is 27x cubed. So I'm going to multiply that by 27, and that will give us minus 945 cubed. Okay, and that should be my expansion up until the x cubed term. And I have to say my range for x where modulus is less than 1, where modulus x therefore is less than 1/3. So we could say negative 1/3 is less than x is less than 1/3. Those were our values for x. Okay, so for our second one, I've got this 1 over the square root of bracket 1 plus x squared, and I need to find the first 3 terms in ascending powers of x. Well, another way of writing this would be 1 plus x squared all to the power of negative 1/2. And therefore, I can go ahead and write my terms. This is going to be 1. My second term is going to be minus 1/2 into x squared. My next term is going to be minus 1/2 multiplied by minus 3/2. Remember, we drop down power each time, all over 2 factorial. And this will be multiplied by x squared. So, what does this give us? 1 minus 1/2 x squared. And let's have a look at this one. I get minus 1/2 times minus 3 over 3/2. So we end up with 3/4, and that will be divided by 2 factorial, which gives us 3/8. So it should be positive 3/8, and this will be x to the power of 4. And those should be the first 3 terms in ascending powers of x. So now, guys, we move on to some more difficult examples. I'm looking at question 11 from the exercise. The first 3 terms of the expansion 1 plus kx to the n are 1 plus 12x plus 81x squared. We have to find the value of k and the value of n. Well, how we do this? We know our first term is going to be 1. Our second term is going to be n times kx. Our next term is going to be n times n minus 1 over 2 factorial times kx all squared. And then we can set up a simultaneous equation. We know that nk equals 12. And the reason for that is this here. It's the same term. And in addition to this, so that's our, well, we could rearrange it slightly. We could say k is equal to 12 over n, okay? So that's my first equation. The second one, we could say, well, look, I've got n squared minus n all over 2 factorial, and that's got to be equal to k squared, times k squared, and that's going to be equal to 81. So here I'm looking at this term here, and this here. That's my little daughter in the background screaming, if you can hear it. She's happily playing with some balls and chasing them around. Okay, so now we could substitute in, couldn't we, this value of k into here. So that's what I'll do. I'm going to multiply both sides by 2 factorial, so my next line is going to look like this. And 12 over n squared is equal to 162. Okay, and if I multiply this out, I'm going to get 144 minus 144 over n is equal to 162. And I could say, what could I say? Minus 144 over n is equal to, and what do we get here? 162, so I think that's 18. And so minus 144 is equal to 18n. So n is equal to 8. So minus 8. Minus 8. 144 divided by 18. Yeah, 8. Okay, so that's the value of n, and therefore, what does k equal? K equals 12 over negative 8, which is equal to, what do we say? 4 goes into both of those, so we'll have 3 over 2, so negative 3/2. Okay, now the second part of the question is we need to find the term in x cubed. Well, if we just carry on, we would have n into n minus 1 into n minus 2. That's all going to be over 3 factorial times kx cubed. Now, we just chuck in our values here. So what do we get for n? N is minus 8, so we're going to have minus 8 times minus 9 times minus 10. That's all going to be over 3 factorial. And that's going to be multiplied by negative 3/2 x cubed. Now what do we get when we do this? We'll get a negative, and negative 3 cubed. I'm getting 405 x cubed. And that should be the answer for that one. Okay, so the last question that we have to work with here is we've got to find the first 5 terms of the expansion of 1 minus 2x times 1 plus 2x squared. I'm going to first of all rewrite this as 1 minus 2x, and then I'm going to multiply it by 1 plus 2x squared, and this will be to the power of negative 1. To expand this, the first 5 powers ascending, I'm going to get the first 4 powers of this equation here, and then I'm going to multiply those by the first bracket, because that will give me an extra power. On second thoughts, I may need actually to get the first 5 powers of this bracket here, actually, because I need to times them by 1 and by minus 2x. So we'll try that. What do I get when I expand the second bracket? Well, I should have 1 as my first term, and for my second term it's going to be minus 1 multiplied by 2x squared. Then my third term is going to be plus, and I'm going to have minus 1 into minus 2 all over 2 factorial, and this will be times by 2x squared, and that will be all squared. My next term will be minus 1 times minus 2 times minus 3, and we're going to be all over 3 factorial this time, and that will be times by 2x squared to the power of 3. And our last term, our fifth term, is going to be minus 1 times minus 2 times minus 3 times minus 4 all over 4 factorial, and 2x squared by to the power of 4. Okay, so let's expand this. We're going to have 1 minus 2x, which is our first bracket. I'm just going to pull this down here, and then I'm going to pull and simplify all these down here. So we're going to have a times by 1. The next one's going to be times by minus 2x squared. The next one, now we're getting a bit more tricky here. We've got 2 over 2 factorial, so that's just 1. So the next term will be 4x to the 4. The next term was going to be, will be negative, so we can get rid of that, negative 8x x to the 6. The next term will be, what can we do? Okay, so 4 factorial, that'll cancel out, so we'll end up being 1 there, so it'll be 16x to the 8. Right, now we're wanting the first 5 terms in this expansion. Well, our first term is going to be 1 times 1, which is 1. Our second term is going to be an x term, right? And we get that by multiplying this and this. Okay, there's no other way that we can get an x term, so it'll be minus 2x. Okay, and then our next term, we're looking for, is there a way of getting an x squared term? And yes, there is. It's going to be this by this. And it seems to me that there's no other way that we can get this, so I should have our minus 2x squared. Is there a way of getting another term, let's say an x cubed term would be the next one. So yes, you can see that if I multiply this and this, and I'm going to get in that case a positive 4x cubed. Okay, and well, let's see, we've almost got our term, so I didn't need to expand as far as I was thinking, but that's okay. Better safe than sorry. My next term is going to be x to the 4 term. How do I get an x to the 4 term? This way here, so it'll be 4x to the 4. Is there any other way of doing it? No. I've got my first 5 terms in ascending powers of x. Let me just check up on that and make sure I'm okay. Yes, I'm happy with my positive 1. That's good. I'm happy with that. My minus 2x, I'm happy with that. There's only one way of doing that. Now my negative 2x squared, yes, I'm happy with that. My 4x cubed, yes, I'm happy with that. And finally my 4x to the power of 4. Yep, I'm also happy with that. And I think that should be my answer for that one. I'll have a go at the questions in this exercise. Some of them are a little bit tricky, but it will set you up for the next exercise. We're going to add a little bit of complexity by changing that 1 at the front of our brackets when we're expanding to something else. Let's see what happens when we do that. Good luck.